What if the greatest gift to life came wrapped in destruction? The Earth once turned in quiet rhythm, its seas stirring under pale skies, its forests stretching across a world ruled by giants. For millions of years, life had flourished in relative peace, unaware that fate was not bound only to the ground beneath its feet, but also to the heavens above. In the silent dark beyond the atmosphere, a wanderer of stone and ice drifted toward its mark. No drum announced its approach. No warning echoed across the lands it would soon erase. An asteroid forged in the fires of creation carried with it the weight of chance. In the vast emptiness, it was one of countless fragments, yet this single body held the power to alter the history of an entire planet. It was a cosmic dice roll cast across billions of miles, a message inscribed in rock long before Earth ever knew the meaning of destiny. When it struck, it shattered more than the reign of the dinosaurs. It reshaped oceans, scarred continents, and filled the air with the fire of endings. Yet in that devastation, the path for something new was cleared. Mammals that once cowered in the shadows emerged into the open. From their survival, thought was born, and with it the fragile miracle of awareness. Without the violence of that impact, humanity itself might never have opened its eyes to the stars. The destroyer became in time the silent architect of possibility. The question remains, was it chance or was it inevitability that life's story would hinge on a single fall of stone? The Earth holds its memories in stone. Each layer of sediment is a page in its diary, pressed and sealed across millions of years. For generations, geologists traced these layers like archivists of deep time, deciphering the rise and fall of oceans, the drift of continents, and the quiet persistence of life. But in one particular band of clay, thin enough to rest between fingers, the story of the world changed forever. It was the late 1970s when a father and son stood on the edge of this mystery. Walter Alvarez, a geologist at the University of California, Berkeley, had been studying the rocks near Gubbio, Italy. The Apennine Mountains rose around him like crumpled parchment, their cliffs layered with fossil-rich limestone. To the trained eye, these rocks were not lifeless stone but the frozen remains of ancient seas. Embedded in their patterns lay a boundary, a thin, dark seam of clay no thicker than a coin. Above this line, fossils of tiny marine creatures known as foraminifera were sparse, reduced, diminished. Below it, they were abundant, diverse, thriving. Something had drawn an unmistakable curtain across the theater of life. Walter brought this puzzle to his father. Luis Alvarez, a Nobel Prize-winning physicist renowned for his sharp, unrelenting curiosity. Together they asked a simple but unsettling question. What event could have caused such an abrupt disappearance of species? To answer it, they turned not to fossils themselves but to the chemistry locked within the clay. The results were startling. The thin boundary layer contained unusually high concentrations of iridium, a metal rare on Earth but common in asteroids and comets. Its abundance was far beyond anything the crust could explain. It was as if the Earth had been dusted with the ashes of the cosmos. Luis Alvarez described it as an extraterrestrial fingerprint, a residue from something violent and immense. In 1980, the Alvarezes published their hypothesis. A massive asteroid had struck Earth 66 million years ago, hurling dust and debris into the sky, darkening the planet for months or even years. Photosynthesis would have collapsed, food chains would have unraveled, and 3/4 of all species, including the great reptiles that once ruled the land, would have perished. The claim was extraordinary, and so too was the skepticism it faced. Many paleontologists had long believed that extinction was a slow process, a gradual fading over geological time, rather than the result of a sudden catastrophe. The asteroid hypothesis challenged not just the story of the dinosaurs, but the very framework of evolutionary thought. Catastrophes, many argued, were too dramatic, too violent, too improbable to shape the steady rhythm of life. Some dismiss the iridium anomaly as volcanic in origin, pointing to the vast lava flows of the Deccan Traps in India, which were active around the same time. Others argued that the data was too thin, too limited to support such an extraordinary conclusion. Yet science thrives on replication, and evidence began to mount. Across the globe, researchers sampled boundary layers in Denmark, New Zealand, Spain, and North America. Each site revealed the same iridium spike, a global signature etched into the skin of the planet. The pattern was undeniable. Something beyond ordinary earthly processes had swept across the world. Still, a hypothesis, no matter how compelling, demands a culprit. If an asteroid truly struck Earth with such force, where was the scar it left behind? For years, this remained the missing piece. Geologists scoured maps, examined gravity data, and searched for circular structures buried beneath oceans and jungles. It was not until the early 1990s that the final clue emerged. In the Yucatan Peninsula of Mexico, oil companies had long surveyed the subsurface in search of hidden reserves. Their seismic data revealed a vast buried structure, a ring more than 180 kilometers wide, half submerged beneath the Gulf of Mexico. It was a crater unlike any other, colossal in scale, with features that spoke of unimaginable violence. This was Chicxulub, named after a small coastal town nearby. The crater matched the timeline precisely. Its formation dated to 66 million years ago, the same moment the dinosaurs vanished from the fossil record. Shocked quartz, tiny glassy spherules, and melt rock were all present, signatures of an impact so immense it dwarfed any volcanic eruption. The energy released was equivalent to billions of nuclear bombs, enough to set forests ablaze on a planetary scale, boil seas along coastlines, and cloak the skies in dust thick enough to blot out the sun. With Chicxulub, the evidence converged. The iridium was the dust of the asteroid itself, scattered into the atmosphere and deposited around the globe. The thin clay layer was not just a mark of extinction, but a record of impact winter, when the Earth's surface froze under a shroud of night. Skepticism gave way to reluctant acceptance, and then to awe. A theory once ridiculed as too extreme became a cornerstone of planetary science. The Alvarezes had not only explained the death of the dinosaurs, but revealed the deep vulnerability of life to the caprice of the cosmos. The discovery carried a sobering weight. Extinction, once thought to be gradual and patient, could arrive in a single catastrophic moment. It meant that Earth's history was not only written by the slow hand of evolution, but also by the sudden strikes of fate. Today, the Chicxulub crater is hidden beneath layers of limestone and shallow sea, invisible to the casual eye. Yet it remains one of the most important scars on the planet, a reminder that in the vast lottery of the universe, chance can overturn even the mightiest reigns. From a thin seam of clay in Italy to a buried crater in Mexico, scientists pieced together one of the most dramatic stories in Earth's history. What began as a puzzle in the fossil record became a revelation that a rock from the heavens had ended one chapter of life's story and opened the way for another. And in that realization lies a paradox. The same blow that ended the age of dinosaurs made space for mammals to thrive, for intelligence to emerge, for a species capable of looking back across time and uncovering the very event that gave it room to exist. The discovery of the asteroid impact is not just a tale of death, but also of unlikely inheritance. Life, fragile and persistent, found a way to rise from the ashes of cosmic violence. The question lingers in the silence of those rocks. If not for that single chance collision, would thought itself ever have found a home on Earth? The revelation struck like a thunderclap across the scientific world. For centuries, the rhythm of Earth's history had been imagined as slow, patient, and deliberate, a symphony conducted over millions of years. Mountains rose grain by grain, oceans shifted in silence, Species faded into extinction not with violence but with gradual decline. This vision, nurtured since the days of Charles Lyell and Charles Darwin, framed the planet as a realm of continuity. Catastrophes in that worldview were interruptions, not architects. And yet the evidence revealed something astonishing. A single asteroid, no larger than a city, could reset the balance of life. In an instant, it had rewritten the biological order of the planet. This idea defied centuries of thought, challenging the very foundation of geology and evolutionary biology. If the Earth could be reshaped in a single heartbeat of cosmic violence, then permanence itself was an illusion. To grasp the magnitude of this event is to enter the realm of incomprehensible numbers. The Chicxulub impactor is estimated to have been roughly 10 kilometers in diameter, a fragment of primordial rock traveling at more than 20 kilometers per second. In the moment of collision, it released energy equal to over 100 million megatons of TNT. To place that in perspective, the most powerful nuclear device ever tested, the Soviet Tsar Bomba, yielded 50 megatons. The asteroid unleashed the force of more than 2 billion such detonations in a single breath. The blast vaporized rock, sea, and atmosphere alike. Temperatures at ground zero soared beyond imagination, hotter than the surface of the sun. Shockwaves rippled through the crust, triggering earthquakes larger than anything humanity has ever measured. Tsunamis hundreds of meters high raced outward, smashing ancient coastlines to pieces. Forests within thousands of kilometers ignited instantly, as the sky itself rained molten glass formed from vaporized stone. But it was not the fire alone that ended the age of dinosaurs. The most profound devastation came from what followed. Trillions of tons of dust and aerosols surged into the atmosphere, forming a veil that wrapped around the planet. The sun dimmed. Photosynthesis faltered. Within weeks, ecosystems began to collapse. The lush greenery that fed the herbivores withered. The predators that relied upon them starved. Food chains unraveled like fragile threads in the darkness. In the fossil record, the suddenness of this extinction is clear. Just below the boundary clay, the world teems with diversity. Ammonites spiraling in ancient seas, towering reptiles dominating land and sky. Just above it, silence. Species that had endured for tens of millions of years vanished in what was, on geological scales, an instant. The line between abundance and absence is drawn with startling sharpness, as if the curtain of existence fell overnight. For scientists steeped in gradualism, the implications were profound. Evolutionary history, once pictured as a slow unfolding, now bore scars of sudden catastrophe. Catastrophism, a view long dismissed as relic of ancient myth and superstition, re-emerged not as fable, but as fact. It was no longer possible to imagine life as sheltered from cosmic chance. The planet was not a stable stage, but a fragile arena vulnerable to forces beyond comprehension. The shock was not limited to academic halls. Philosophically, it shook humanity's sense of permanence. Civilizations had built their identities upon the idea of endurance. Mountains would always stand, oceans would always return, and the heavens, though mysterious, were constant. The asteroid impact revealed a universe governed not by certainty, but by chance. A random wanderer of stone, drifting unseen across the void, had altered the fate of life itself. This realization forced a deeper reckoning with humanity's place in time. If extinction could strike with such sudden ferocity, then the story of life was not one of inevitable progress, but of fragile survival. The dinosaurs, once rulers of the earth, were undone not by weakness but by chance. Their reign of more than 160 million years ended not through decline, but in a moment of violent interruption. Their loss opened a door for mammals, but it was a door unlocked by catastrophe, not destiny. The scale of devastation is almost impossible to translate into human terms. Imagine the entire arsenal of nuclear weapons on Earth detonated simultaneously and then multiplied thousands of times over. The energy of Chicxulub dwarfed even that. It was a planetary event, reshaping not only landscapes but the trajectory of biology itself. In those moments, Earth was less a cradle of life than a crucible, purging one era to prepare for another. Yet the astonishment extended further, for if one asteroid had wrought such change, it meant that countless others still roamed the solar system. The heavens, once perceived as distant and serene, became a reservoir of latent threat. Each orbiting fragment of stone carried with it the potential to repeat history. Suddenly, extinction was not only a relic of deep time but a possibility for the future. Humanity, for the first time, was forced to imagine itself within the same precarious frame. This knowledge seeded a subtle unease. Beneath the comfort of modern civilization, the memory of Chicxulub whispered that permanence is fragile and safety temporary. Earth is not insulated from cosmic chance. It is exposed, vulnerable, a small blue sphere adrift in a sea of wandering debris. But within this shock, a paradox emerged. The asteroid that ended one chapter also made possible the rise of another. Without that cataclysm, mammals may never have thrived. Without their ascendants, intelligence may never have blossomed. And without thought, there would be no awareness of the event at all. Humanity owes its very existence to the destruction of worlds past. In that paradox lies a profound reflection. Life is both fragile and resilient, extinguished in an instant yet capable of renewal. The Chicxulub impact forced science to abandon comforting illusions of slow, steady permanence. It revealed that Earth's history is punctuated by calamities as well as continuities. It reminded us that survival is not guaranteed, and that chance has shaped the path of evolution as much as adaptation. The shockwaves of that discovery continue to resonate today. The iridium layer is no longer just a line in stone, nor Chicxulub a buried crater beneath the sea. They are reminders etched into the collective memory of science. They tell of a universe both creative and destructive, where endings are inseparable from beginnings. To accept this truth is to confront both terror and wonder. Terror, because it reveals how little control life has over the vast machinery of the cosmos. Wonder, because it shows how existence itself is a consequence of improbable survival. The day the asteroid struck, 3/4 of Earth's species vanished. Yet from that silence emerged the possibility of thought, memory, and reflection. Humanity now gazes at the stars with the knowledge that it, too, is vulnerable, but also with the understanding that even in destruction, the seeds of new life can take root. The discovery of the Chicxulub impact did more than explain the fate of the dinosaurs. It reframed the nature of life's journey. It showed that the Earth is not simply a sanctuary, but a stage upon which chance and necessity perform their endless dance. And it left behind a haunting question. How many other worlds, unseen and silent, have been shaped by the sudden fall of stone? The Earth remembers violence in its bones. Beneath layers of limestone, sandstone, and clay lie silent records of moments when the ordinary rhythm of geology was torn apart. In the case of the Chicxulub impact, those records are unmistakable. They are written in crystals shattered under impossible pressure, in droplets of glass born from molten stone, in layers of debris that speak of oceans rising higher than mountains. When geologists first drilled into the Yucatan Peninsula, they did not uncover mere rock. They unearthed fragments that bore the scars of an instant catastrophe. Microscopic grains of quartz were fractured in patterns that only occur when stone is struck with sudden, colossal force. This shocked quartz is the fingerprint of an impact, a mineral scarred by shockwaves traveling faster than sound through the crust. Nearby, geologists discovered tektites, glassy beads formed when rock is vaporized and hurled skyward, cooling into droplets before falling back to Earth. These tiny spheres, scattered across continents, are relics of the firestorm that followed the collision. Far from Mexico, the sea itself had preserved other memories. Along ancient coastlines, thick layers of disturbed sediment mark the passage of titanic waves. Tsunami deposits stretch across the Gulf of Mexico and beyond, filled with jumbled shells and sand torn from the ocean floor. These layers tell of walls of water racing outward at nearly the speed of sound, reshaping entire shores before retreating back into the depths. The ocean had risen against the land with the force of continents colliding, and it left behind scars that would outlast the species who bore witness. To understand what such an impact truly meant, scientists turned to simulations. With the tools of modern computing, they recreated that ancient day, frame by frame, moment by moment. In these models, the asteroid's entry is swift and merciless. Traveling at more than 20 kilometers per second, it tore through the atmosphere in a blaze of plasma. Within a fraction of a second, it struck the shallow seas of the Yucatan. The ocean boiled instantly. The crust shattered. A crater nearly 200 kilometers wide opened in a heartbeat, its central peak rising and collapsing like a wound pulsing with energy. The immediate aftermath was a chain reaction of destruction. Rock and water vapor were blasted into the stratosphere. Trillions of tons of pulverized stone were ejected into the sky, glowing as they rained back down through the atmosphere. The returning ejecta heated the air to oven-like temperatures, igniting forests and sweeping fire across continents. Yet the greatest threat was still to come. The dust and aerosols released by the impact spread quickly, wrapping the planet in a shroud. Sunlight dimmed, then nearly disappeared. Photosynthesis, the foundation of Earth's food web, faltered and collapsed. Without sunlight, plants withered. Without plants, herbivores starved. And without herbivores, predators fell in turn. Within months, ecosystems that had thrived for millions of years unraveled with terrifying speed. This was Earth's version of nuclear winter, though no human hand had launched the fire. The term, coined decades later to describe the consequences of atomic war, perfectly captures what followed. For years, the planet remained veiled in a twilight haze. Temperatures plummeted. Acid rain, formed as sulfur-rich aerosols mixed with water vapor, poured across the land and seas. Oceans grew more acidic, disrupting delicate marine life. The great reptiles of the Mesozoic, from the colossal sauropods to the swift raptors and soaring pterosaurs, were undone not only by fire and flood, but by the slow starvation of a darkened world. The fossil record testifies to the suddenness of this collapse. In deposits across North America, rich beds of dinosaur bones abruptly cease above the boundary clay. Entire groups vanish without trace. Ammonites, once masters of the seas, disappear in a geological blink. Coral reefs, intricate and ancient, crumble and vanish. Foraminifera, microscopic architects of marine ecosystems, decline from dazzling variety to a handful of survivors. Life, in its grand diversity, was pared back to fragments, and yet amid the silence, resilience stirred. Small mammals burrowing beneath the soil endured the famine and cold. Crocodiles, adapted to survive long periods without food, lingered in swamps and rivers. Some birds, distant relatives of dinosaurs, managed to weather the storm, giving rise to the avian lineage that still fills the skies today. What the impact extinguished in grandeur, it preserved in potential. To study these records is to witness an apocalypse in slow motion, unfolding across stone and fossil. Each piece of evidence, the shocked quartz, the tektites, the tsunami layers, is a thread in a tapestry of destruction, woven across the globe. Together, they tell of a moment when Earth was thrown into shadow, when permanence itself seemed fragile, when life clung to survival by the thinnest of margins. The more scientists investigated, the more haunting the picture became. The Chicxulub impact was not merely a local disaster, but a planetary reset. Its echoes reached every ocean, every forest, every sky. The dinosaurs, who had reigned for more than 160 million years, were gone in less than a geological heartbeat. In their place, a new world slowly emerged. Fragile at first, but destined to give rise to intelligence, reflection, and memory. The deeper the investigations went, the clearer it became The boundary between life and death was written not in slow decline, but in an instant of cosmic chance. A rock adrift in the void, born from the earliest days of the solar system, had intersected with Earth at precisely the wrong, or perhaps the right, moment. Philosophically, the discovery carried an unsettling weight. If one asteroid could do this, then the story of life itself might be less about inevitability and more about contingency. Existence was not guaranteed but borrowed. The dinosaurs' extinction was not a slow surrender, but a sudden eviction. And from that void, mammals inherited a fragile stage upon which to build the next act of evolution. The crater, buried beneath limestone and sea, remains both scar and symbol. It is a reminder that the Earth is not a closed system, but a participant in the wider drama of the cosmos. It is vulnerable to forces beyond its atmosphere, to events that occur rarely yet with consequences so immense they reshape the future of life itself. The fossils and rocks unearthed from this cataclysm whisper a truth both terrifying and profound. That life is resilient but never invulnerable. That survival is written not only in adaptation and evolution, but in the ability to endure catastrophe. And that the very existence of humanity, its awareness, its reflection, its gaze upon the stars, is tied to the silence left by a single fall of stone. The deeper scientists investigated, the more they realized they were not simply studying the death of the dinosaurs. They were uncovering the conditions of their own existence. Chicxulub was not only the end of one world, but the unlikely beginning of another. And so the rocks still speak. In their fractured crystals, their glassy droplets, their buried bones, lies the memory of a day when fire and darkness ruled, and from which the future of life was born. From the ashes of ruin, life began again. The asteroid that erased the age of giants left behind more than silence. It cleared a stage. It carved absence into the world so that new stories might unfold. This paradox, that annihilation can be a cradle, is one of the deepest mysteries in Earth's history. For 165 million years, dinosaurs had been the architects of dominance. They grew into forms both terrifying and elegant, predators with jaws strong enough to splinter bone, herbivores that rose higher than trees, flyers that turned the sky into their domain. They had survived volcanic upheavals, shifting continents, and countless evolutionary challenges. To lesser creatures, their supremacy seemed eternal. Mammals, by comparison, were little more than shadows. Small, nocturnal, furtive, most weighed less than a modern house cat. They scurried in the dark, feeding on insects and seeds, their lives confined to the margins of a world already claimed. What chance could such fragile beings ever have against titans? In a stable world, perhaps none. The niches were filled, the balance set. The dinosaurs' size and power secured their reign. Evolution, left to run without interruption, might never have lifted mammals beyond obscurity. But the asteroid did what slow time could not. It broke the pattern. In an instant, it stripped away the dominance of one lineage and left behind an emptiness. Ecological niches, once sealed by reptilian power, now stood open. Forest canopies once filled with thunderous footsteps lay quiet. Skies once shadowed by wings stretched empty. The world's balance had been undone, and in that void, possibility bloomed. The survivors were not the strongest. They were the adaptable, the hidden, the small. Mammals, spared by their burrows, their varied diets, and their ability to endure lean seasons, emerged into landscapes no longer ruled by giants. For the first time in Earth's history, the shadows belonged to them. What followed was an escalation unlike anything the planet had seen since the Cambrian explosion. Fossil records reveal that within a few million years, a blink of geological time, mammals began to diversify with startling speed. Lineages that had once been confined to narrow roles spread outward, exploring the ecological opportunities left vacant. Some evolved into swift runners, reclaiming the plains. Others grew larger, taking up the roles of herbivores once held by hadrosaurs and ceratopsians. Predatory forms sharpened their teeth and claws, filling niches left by tyrannosaurs. The world, once sculpted by reptilian bodies, now reshaped itself around fur and warm blood. Among these early mammals, the seeds of something extraordinary were already present. Tiny primates clinging to branches in the shadows of newly regrown forests began their quiet ascent. Their grasping hands and forward-facing eyes set them apart, giving them a depth of perception that would one day shape tools, art, and thought itself. The asteroid's violence, in this light, becomes more than destruction. It becomes a strange form of creation, a hand clearing the canvas so that new strokes might be painted. Without its intervention, the lineage that would become humanity might have remained hidden in obscurity, never given the chance to rise. Yet the mystery deepens. Was this simply chance, or was it part of some larger inevitability? If the asteroid had missed by only a fraction of space and time, the dinosaurs might still walk the Earth. Would mammals have ever stepped into their place without that singular moment of catastrophe? Or was evolution already preparing them, slowly but inexorably, for their turn at dominance? Some scientists argue that mammals were already primed for success. Warm-blooded metabolism allowed them to thrive in varied climates. Their ability to birth live young and nurture them with milk gave offspring a stronger start. Their intelligence, modest though it was, offered flexibility. Perhaps, even without an asteroid, mammals would eventually have carved a larger role. Yet without the sudden clearing of the ecological stage, such a rise might have taken tens of millions more years, if it happened at all. The paradox is haunting. The dinosaurs' extinction was both a tragedy of loss and a necessity for what followed. The grandeur of their reign ended in fire and darkness, yet from that same darkness came the dawn of possibility. Life did not retreat into simplicity. It escalated, growing richer, more varied, more experimental. The Earth, scarred by catastrophe, became a laboratory of innovation. Philosophically, the question lingers. Is life's progress shaped more by resilience or by randomness? The Chicxulub impact was not guided by intent. It was a stone wandering through space, drawn by nothing more than gravity and chance. Yet its collision gave rise to minds capable of reflecting on that very randomness. Intelligence, consciousness, awareness, all may trace their lineage to the accident of an asteroid's fall. In this paradox lies a truth both unsettling and profound. Catastrophe is not only an end, but a force that reshapes beginnings. Destruction is not the opposite of creation, but often its hidden companion. Without one, the other may never emerge. The fossil record shows that mammals, once freed from the shadow of reptiles, multiplied into astonishing diversity. Within 10 million years, early forms of horses, whales, and primates had begun to emerge. Some took to the water, some claimed the skies, and others remained in forests and plains. The evolutionary branches spread outward like a tree newly unbound. Each twig a gamble, each leaf a possibility. And among those branches, one line of primates carried within it the potential for something the planet had never seen before, the ability to wonder, the ability to look back across time and see meaning in stone and fossil, the ability to recognize that their very existence was tied to the silence left by a single day of fire. The paradox endures as a question whispered across ages. Was the rise of mammals inevitable, waiting only for the right moment? Or was it born of pure accident? If another asteroid had struck in a different age, might an entirely different lineage have risen to intelligence? Could the Earth have been a world of reptilian thought or avian civilization? Or perhaps no thought at all? What is certain is that destruction and creation are inseparable in the story of life. The asteroid's blow was both an end and a beginning, a single stroke that erased one symphony and gave space for another. In its aftermath, the small became mighty, and the forgotten became central. From insignificance, mammals rose to shape the future. The escalation of life after Chicxulub is not only a scientific story, but a philosophical one. It tells that permanence is fragile, that dominance is temporary, and that chance holds sway over destiny. Yet it also tells that from fragility comes resilience, from loss comes renewal, and from silence comes song. Today, when humanity gazes at the stars, it does so with the awareness that its place in the cosmos was born of catastrophe. The asteroid that ended the dinosaurs gave rise to the conditions that would, millions of years later, allow minds to ponder the very nature of existence. The paradox remains unresolved. Was it accident or inevitability that life's path turned on the fall of stone? The answer may never be known, but what is known is this: from destruction came possibility, from silence came voices, and from the ashes of giants came the fragile yet extraordinary spark of thought. The Chicxulub impact explained much, but not everything. In the search for truth, science rarely rests on a single cause. The extinction that reshaped Earth was not merely an isolated event, but perhaps the convergence of forces, the intertwining of fire from the sky and fire from within the Earth itself. In India, across the Deccan Plateau lies a scar almost as vast as the crater in Yucatan. Layer upon layer of hardened basalt stretches for hundreds of thousands of square kilometers, evidence of one of the largest volcanic outpourings in Earth's history. Known as the Deccan Traps, this eruption released rivers of lava that flowed for tens of thousands of years. Alongside the molten rock came gases, carbon dioxide, sulfur dioxide, and countless aerosols, each altering the fragile balance of climate and chemistry. Some researchers argue that this volcanism played as crucial a role as the asteroid. Long before the impact, ecosystems were already under strain. Volcanic emissions may have warmed the climate, acidified oceans, and stressed species to the brink. In this view, the asteroid was not the sole culprit, but the final blow to a world already weakened. Others suggest the two events may even be linked, that the energy of the impact itself could have triggered pulses of volcanic activity on the far side of the globe. Catastrophe, then, may not have been singular but compounded, a chorus of destruction rather than a solitary note. The interplay between volcanism and impact remains debated, but in one sense, the details matter less than the larger revelation. Life is not undone by one force alone. It is subject to the convergence of many: chance, environment, and cosmic happenstance woven together into a tapestry of endings and beginnings. Yet speculation stretches beyond geology into the realm of philosophy. The Chicxulub asteroid was a chance visitor. Had its orbit shifted by even a fraction, it might have sailed harmlessly past. What then would have become of Earth? The anthropic principle offers one unsettling reflection. Intelligence can only ask such questions in a universe where the conditions allowed intelligence to arise. Humanity exists because the asteroid struck. In universes where it did not, no voice emerges to ponder the silence. If the dinosaurs had endured, perhaps they would have remained dominant, their evolutionary momentum too strong for mammals to overcome. Would intelligence have ever risen in such a world? Some scientists have dared to wonder whether dinosaurs themselves might have evolved toward higher cognition. Certain groups, like the troodontids, possessed relatively large brains for their size, grasping hands, and keen senses. Could time, left undisturbed, have sculpted them into creatures of awareness? Could Earth have become a world where reptilian minds pondered the stars, where scaled philosophers carved symbols into stone, where feathered architects raised monuments not to gods, but to memory? Speculation paints these visions, but evidence remains elusive. Evolution is not destiny. Intelligence is not inevitable. It is an accident layered upon countless others, a product of circumstance as much as adaptation. Mammals inherited the stage not because they were destined to rule, but because chance erased their competition. In another timeline, another universe, perhaps the story diverged. The multiverse hypothesis suggests there may be infinite Earths, each branching from the rolls of cosmic dice. In some, the asteroid missed, and the dinosaurs still thunder across plains. In others, volcanism alone reshaped the planet. In still others, neither catastrophe occurred, and the evolutionary script meandered along paths unimaginable. Humanity may be but one verse in an endless chorus of possibilities, a single fragile variation in the song of creation. This speculation, though unprovable, sharpens the paradox. Life as it exists today arose from destruction. Humanity, with its capacity for reflection, its search for meaning, its gaze that stretches beyond the stars, is the heir not to stability, but to catastrophe. Without fire from the sky, there may have been no thought, no art, no memory. Intelligence is, in this sense, the child of ruin. Philosophically, this truth unsettles and inspires in equal measure. It unsettles because it denies permanence. It inspires because it shows resilience. Creation and destruction are not opposites but partners. One makes room for the other. The death of the dinosaurs was not simply an ending, but the opening of a door. Through it walked mammals, carrying within them the seeds of awareness. In every fossil of Chicxulub's aftermath lies a whisper of this paradox. In the shattered quartz and the glassy tektites, in the bones of vanished species, in the first stirrings of mammalian diversity, the message is the same. From death comes life, from silence comes song, from endings come beginnings. This reflection extends beyond Earth. Across the universe, planets orbit suns, some scarred by impacts, some smothered by volcanism, some perhaps untouched by catastrophe. On those worlds, what stories of life unfold? Are there planets where catastrophe never struck, where dominant species endured for hundreds of millions of years, stable but unchanging? If so, does intelligence stagnate, never push to rise from obscurity? Or is it only through disaster that creation is jolted into new directions? Speculation stretches further still. If intelligence exists elsewhere, what scars does it carry from its own past? Do alien civilizations owe their existence to their own Chicxulub, their own improbable catastrophe that cleared the stage for thought? Or are we alone in tracing our consciousness to the violence of an asteroid's fall? Theories multiply, but they circle the same central paradox. Life advances not in spite of death, but through it. Creation is not untouched by destruction, but entangled with it. The Earth's story is not a tale of steady ascent, but of interruptions, resets, and improbable survivals. Humanity's presence on this planet is not the fulfillment of inevitability, but the outcome of chance. Chance written in stone, chance delivered by fire. To contemplate this is to confront both humility and wonder. Humility, because it reveals that the arc of existence rests on fragile contingencies. Wonder, because it shows how those contingencies can give rise to awareness capable of grasping them. The asteroid strike is long past, yet its echo remains in every thought, every word, every dream. The debate between volcanism and impact will continue. The possibility of multiverses may remain forever beyond proof. The question of dinosaur intelligence may linger in speculation. Yet all these theories converge on a single truth. Life's path is neither straight nor secure. It is carved by fire, sculpted by darkness, and renewed in ways no creature within it can foresee. The paradox endures: creation through destruction, life through death, memory through silence. Humanity, in its brief span, is both the witness and the product of that paradox. Without the asteroid, there may have been no eyes to look upward, no minds to wonder, no voices to narrate the story of catastrophe turned to possibility. And so the mystery deepens. Was it chance alone that guided the asteroid to Earth, or was it the unfolding of an inevitability written into the cosmos? Was intelligence destined to arise, or is it the most fragile accident of all? The answers remain hidden, scattered among the stars. Yet the very act of asking reveals the gift born from destruction, the capacity to wonder. The Chicxulub impact belongs to a past so distant it seems almost mythical, yet its traces remain etched in stone, waiting for modern science to decipher them. In the last half-century, researchers have turned to new tools, seeking not only to reconstruct what happened on that day 66 million years ago, but to prepare for the possibility that it could happen again. In the Yucatan Peninsula, an international team began one of the most ambitious geological investigations of our time. Drilling deep into the buried Chicxulub crater, they extracted long cylinders of rock, each core a time capsule carrying whispers from the day the world changed. These samples revealed the sequence of chaos, layers of melt rock, glassy spherules, shocked quartz, and sediments laid down by the tsunamis that surged outward. They preserved the record of the impact not as theory, but as direct evidence, a geological diary written in stone. From these cores came more than confirmation. They told of how life returned. Just years after the cataclysm, microscopic algae began to reappear in the seas above the crater. Within 200,000 years, ecosystems were recovering, coral reefs reestablishing themselves, and marine food webs knitting back together. The crater was not only the site of death, but also the first seedbed of renewal. The lesson was profound. Even in devastation, resilience stirs. Modern science has gone further still, using satellites to scan the Earth in exquisite detail. From orbit, gravity maps trace hidden structures, revealing circular scars long buried beneath oceans and forests. Seismic surveys send sound waves deep into the crust, echoing back the outline of craters unseen by the human eye. Three-dimensional reconstructions bring Chicxulub to life again, allowing scientists to simulate the moment of impact and watch as energy rippled outward, reshaping the planet. These digital ghosts are not mere images. They are windows into catastrophe, replaying the event with the precision of physics and mathematics. The search extends beyond Earth. Our moon, barren and unchanging, carries the record of impacts across billions of years. Its surface is a museum of scars, each crater a reminder that cosmic collisions are not rare, but inevitable over deep time. Mars too bears the signs, basins so vast they dwarf Chicxulub, created by impacts in the earliest days of the solar system. By comparing these extraterrestrial scars with those on Earth, scientists gain perspective. Our planet has been struck many times, but erosion, weather, and plate tectonics erase most traces. The Moon and Mars remain as archives, silent witnesses to a history of violence that our world, with its restless geology, tries to forget. These comparisons sharpen the realization that Earth is not immune to future encounters. Across the solar system, countless asteroids and comets still wander, many crossing paths with Earth's orbit. Known as near-Earth objects, they are tracked relentlessly, their orbits mapped and their risks assessed. Astronomers scan the skies night after night, searching for new arrivals, calculating probabilities, and issuing warnings when trajectories intersect too closely with our planet. The lesson of Chicxulub has shaped this vigilance. The asteroid that ended the age of dinosaurs reminds humanity that planetary defense is not a luxury, but a necessity. It has inspired missions that move from theory to practice. In 2022, NASA's DART mission deliberately struck a small asteroid named Dimorphos. The collision altered its orbit, a proof of concept that humanity, for the first time, might have the ability to deflect a celestial threat. It was a modest test compared to Chicxulub's scale, but symbolically it was immense. It marked the first moment life on Earth acted to defend itself against the cosmos. Planetary defense strategies are still in their infancy, but they are growing. Proposals include kinetic impactors like DART, gravity tractors that tug an asteroid slowly over decades, and even nuclear devices designed to fragment or deflect dangerous bodies. Each idea stems from the same haunting memory. 66 million years ago, the Earth had no defense. Today, intelligence offers the possibility of choice, yet uncertainty remains. Some researchers ask whether impacts are truly random, or if they follow cycles written into the structure of the cosmos. Studies of craters suggest possible periodicities, impacts clustering at intervals of tens of millions of years. Some propose links to the solar system's oscillation through the galactic plane, where gravitational tides might stir comets from the distant Oort cloud. Others see only coincidence, randomness in patterns too sparse to draw firm conclusions. Still, the possibility of cosmic cycles lingers, raising questions about whether Earth is overdue for another great collision. In these speculations lies a philosophical echo of Chicxulub itself. The asteroid was both an accident and a turning point. It destroyed one world and made another possible. Now, as humanity watches the skies, it must grapple with the knowledge that such events are not relics of prehistory, but possibilities of the future. The very act of searching for near-Earth objects is a recognition that history need not repeat if vigilance and preparation prevail. The tools of science continue to refine this vigilance. Infrared telescopes peer into the dark, where faint asteroids reveal themselves against the blackness of space. Radar imaging maps their shapes and spins with exquisite detail. Computer models project their orbits centuries ahead, predicting whether a fragment of stone might one day intersect Earth's path. And beneath it all lies the shadow of Chicxulub, the reminder of what happens when the warning is absent and chance holds sway. The cores drilled from Yucatan, the satellites mapping Earth's scars, the telescopes tracing asteroids across the night sky. All these efforts converge on a single idea. To understand the past is to prepare for the future. Chicxulub is no longer only a story of extinction. It is a lesson, a warning, and perhaps a gift. The awareness that catastrophe need not always mean surrender. Still, questions remain unanswered. Are impacts simply the background noise of planetary existence, or do they follow rhythms written in the architecture of the galaxy? If cycles exist, what cosmic pendulum swings above us, invisible yet inexorable? Humanity stands in a rare position, aware of the threat, capable of studying it, perhaps able to act against it. Yet the scale of the cosmos dwarfs all certainty. The asteroid belt still hums with countless wanderers. The Oort cloud, stretching trillions of kilometers away, harbors comets that could one day descend. The universe is a reservoir of possibility, some creative, some destructive. What modern science offers is not certainty, but vigilance. The scars of Chicxulub, uncovered by drill and satellite, whisper of fragility. The skies scanned by telescopes remind of vigilance. And the test of DART signals a turning point. Life, once a victim of catastrophe, may one day stand ready to prevent it. In reflecting on these tools and efforts, one sees not just science, but philosophy. Humanity is the first species on Earth to uncover its own vulnerability, to recognize that survival depends not only on adaptation, but on foresight. The memory of Chicxulub lingers not to terrify, but to instruct. It reminds that the universe is not a gentle cradle, but a restless sea, and survival lies in learning to navigate its storms. The story is unfinished. The drilling continues. The satellites refine their maps. The telescopes widen their gaze. Each discovery adds to a narrative that began with fire in the sky and darkness on the ground. A narrative that still unfolds in laboratories and observatories, in the silent watch of astronomers charting paths of wandering stone. And through it all, the question persists: is catastrophe a recurring rhythm of the cosmos? Or was Chicxulub a singular stroke of chance? The answer remains hidden, but the search itself is a testament to the lesson learned from that ancient day. Catastrophe may arrive again, or perhaps for the first time in Earth's history, intelligence will stand ready to meet it. The story of Chicxulub is not only a tale of destruction, it is a meditation on fragility, on chance, and on the improbable threads from which existence is woven. 66 million years ago, a fragment of stone drifting through space intersected Earth's orbit. In less than a heartbeat of geological time, it ended the reign of the dinosaurs, plunged the planet into darkness, and reset the course of life. That moment, violent and merciless, became the silent architect of everything cherished today. Without it, mammals might have remained in the shadows, small and unnoticed. Without it, primates might never have climbed from forests, their eyes seeking new horizons. Without it, no awareness would exist to reflect on the universe, no voices to ask where life came from, no minds to wonder at the stars. Every thought, every memory, every dream is a ripple from that collision, an echo of fire and silence that unfolded long before humanity was conceived. This truth forces reflection on the meaning of existence itself. If life as it is now depends on an accident, what does that say of its value? Perhaps it is not diminished by its improbability, but heightened. Fragility makes it precious. The fact that thought exists at all, born from chaos and destruction, lends it a weight far beyond certainty. Meaning may not arise from inevitability, but from unlikelihood. Each heartbeat is a triumph over extinction. Each gaze at the night sky a defiance of silence. The universe emerges in this story not as a gentle parent, but as both destroyer and creator. Stars forge elements in their fiery cores, then scatter them in explosions that tear galaxies with brilliance. Planets are born in collisions of rock and dust. Life itself emerges from a world scarred by impacts, shaped by tectonics, stirred by climate and chemistry. Creation is never separate from chaos. The asteroid that ended one chapter of life also began another, just as supernovae seed galaxies with the matter from which new stars are born. The cosmos does not choose, yet it shapes destiny all the same. Humanity's existence in this light becomes an act of inheritance. In every cell lies the story of survival against odds. In every thought lies the memory of destruction turned to possibility. The echo of Chicxulub is present not only in rocks and fossils, but in consciousness itself. Awareness is the distant consequence of an ancient firestorm, the flowering of resilience in the aftermath of ruin. And so, the paradox deepens. Life arises not in spite of death, but through it. Intelligence blooms not in a garden of certainty, but on the fractured soil of catastrophe. The asteroid reminds that stability is an illusion, that permanence is fragile, that existence is contingent on events far beyond control. Yet it also reminds that from fragility comes strength, from chance comes wonder, from endings come beginnings. When humanity looks to the stars, it looks with knowledge inherited from that collision. The awareness of near-Earth objects, the missions to test planetary defense, the vigilance of telescopes scanning the skies, all are extensions of a lesson learned in fire. The past has given the present not only existence, but responsibility. To understand Chicxulub is to recognize that life can be extinguished, but also that intelligence has the power to resist fate. Yet beyond defense, there remains philosophy. Why does existence matter? If the asteroid had missed, the story would be different. Perhaps no humans, no history, no reflection. The multiverse may hold countless such worlds, silent and unaware. But in this universe, in this timeline, thought emerged. Perhaps the meaning of life lies in that improbability itself, that out of endless silence, consciousness exists at all. That in a cosmos indifferent to survival, there are minds capable of awe. The asteroid's echo still resonates. It reverberates in every fossil that marks absence, in every mammal that rose from obscurity, in every human heartbeat that carries the fragile flame of awareness. It hums in the quiet of the night sky, in the questions whispered to the stars. It is a reminder that existence is not guaranteed, but borrowed, that life is fleeting, but luminous. The violence of Chicxulub was unimaginable, yet without it, there would be no eyes to see the universe, no hands to shape tools, no voices to tell stories. Humanity owes its existence to a moment of chaos beyond comprehension, a single stroke of chance written in stone. The universe destroyed, and in destroying, it created. From silence, it gave rise to song. As the Earth continues its journey around, the sun, as comets and asteroids still drift in the deep, that ancient lesson endures. Life is fragile. Life is improbable. And because of this, it is precious beyond measure. The story closes not in despair, but in wonder. For every thought, every dream, every gaze at the stars carries within it the echo of that asteroid. A whisper, across time that says, "From destruction came the possibility of you."